Hello guys, good evening.
Good evening, sir.
Good evening, sir.
So if you are talking about a cable structure, so first thing we should understand in our mind that if these are cable, generally we will consider them as inextensible.
Sir, good evening.
Yeah.
Sir, Ramesh struggled for login. Can you wait for 2 minutes?
Okay.
Okay, sir.
So these are axially, these are the assumptions that we'll consider normally, and we will also consider that shear force will be is equal to 0 and bending moment is equal to 0 everywhere. So if we are talking about a cable structure, that means it will resist loads through axial only, or we can say axially loaded. Even though suppose if we talk about the bar, even though the bar they also take the axial load, but what is the difference here compared to the bars? Bars can take compression as well as tension. But whenever you are talking about cables, obviously they will exist only the tensile forces, or they will resist only the tensile forces. If you take a cable and if you compress it, what do you think? It won't, right? But if you take a cable, take a rubber band and try to expand it, there will be some resisting force generates. But if you take a rubber band and if you compress it, nothing. It's just easily moldable. So if it is a cable structure, it will resist only tensile types of loads only, and bending moments are is equal to 0 everywhere. Suppose, let us say if I imagine there is a cable. What do you think? Suppose if I apply a load at this point, let us say somewhere around 10 kN. If this is a cable and if I apply a point load at anywhere, unlike the beams, what do you think? Will it deflect like this? No, what happens? Because of the loading, if you apply any loading on cable, obviously the position of the cable changes. So depending on the type of the loading, the orientation of the cable will be changes. Now what will be your final orientation? The final orientation will be somewhere like this. Instead of a point load, if we apply 2 point loads, how it may behave? What is the final position of the cable? Depending upon the values and then distances, the position of the cable may be like this, point load and then point. Similarly, what if I apply a uniformly distributed loading? Can you tell me, or can you give me a best example for a similar type of cable subjected to UDL loading? You might have done the surveying. If you imagine a chain over there, obviously it will have this self-weight. So if 2 people are holding at one point and another end, if you can remember, the final position of the cable might be like this. So unlike the other type of structures, depending upon the type of loading, the orientation of the cables changes. Now look at this, and can you tell me what is the degrees of freedom here? What is the degree of freedom that?
2, sir.
Yes.
2, sir.
How much?
2, sir.
2
degree of freedom.
How many reactions will develop here? How many
2,
reactions will develop here? 2.
2.
So total 4. How many equilibrium equations we have? Equilibrium equations will be same, whatever may be the structure. 4 minus 3, 1. Can I further reduce this, or can I take it as only 1? What about the moment at this point?
0, sir.
Not only at this point, even though whatever the point you consider will take the moment as 0, but generally, if you take the moment at this point, that can be sufficient. Even similarly, if you come to this case, 4 reactions, and what about -3, 1, and how many equilibrium equation, next additional equations we can consider? Here also moment is equal to 0. Here also moment is not only at 2 points. Moment can be 0 here, moment can be 0 here, moment can be 0 here. Anywhere you can consider. So can I limit the number of equations in this case?
No.
I cannot, right?
Yes,
But I
sir.
can say, can I say more than 1?
Yes, sir.
Additional equations, you can take n number of points, 1, 2, 3, 4, like that you can take n number of points. At the end of the day, I can say they can be more than 1. If they are more than 1, what is your indeterminacy? Will it be greater than 0 or will it be less than 0?
Less than 0.
Less than 0, right? We have discussed one thing. If indeterminacy is equal to 0, we have discussed that it is determinate. If it is greater than 0, we have it as indeterminate. If it is less than 0, we have discussed it as a unstable.
Unstable.
But what do you think? Is this unstable or stable? Think in a physical point of view. Imagine there is a cable. 2 guys are holding at this point and at this point, and you are applying 2 point rules. What do you think? Is it stable or unstable?
Stable, sir.
Obviously it will be stable. So if you are talking about cable structures, even though the indeterminacy is less than 0, but still we can consider this as a stable structure, right? Now, imagine there is a load of 10 kilonewton, and then this 2 meters, 3 meter, and the sag given as 1 meter. Can you find out the reactions? We don't need of any extra knowledge to solve the unknown reactions of cable. Look at this diagram and can you inform me how can we find the reactions? First of all, tell me, can I find all the unknown reactions or not? How many unknown reactions are there? Reactions at the support: vertical reaction at A, horizontal reaction at A, vertical reaction at B, horizontal reaction at B. And then I can say this is the point C, tensile force in the member AC, and also tensile force in the member BC. First of all, tell me, can I correlate any of these quantities? Can I correlate these two and this? Can I correlate these two and this? How the forces are transforming through support A? Is this 10 kilonewton directly transforming or is it transforming to cable AC?
Cable AC, sir.
Cable AC, right? If I draw the free body diagram at point A, there might be unknown vertical reaction, let us say VA, and also there might be unknown horizontal reaction HA. And also, what about the cable force? As it is a tensile, this was the representation of the tensile force. Now, can you tell me, like, if I know the tensile force in the cable, what can be my HA and what can be my VA?
Says TAC cos theta.
If angle is theta, then obviously my horizontal reaction is TAC cos theta, and here it will be TAC sin theta, right? Similar to the support B also, right? So if I can find the TAC and TBC, I can find the support reaction. Now tell me, how can I find out the forces in these two members? Or how can I find the forces of member TAC and member TBC? Can you give me an idea? How can I find out them?
concurrent forces there.
You see, if this is in equilibrium, at point C, how many forces are there then now? We would
One. Downward one.
applied force is 10, tensile force in the member BC, and also tensile force in the member AC. If this is in equilibrium, can't I apply Lami's theorem? Let us assume this is angle theta 1, theta 2, theta 3. Can you tell me according to Lami's theorem or according to sine rule, what can I write down here? Have you forgotten Lami's rule? I think I have discussed this with you. What is the sin if I am taking 10 divided by what I have to take? I have to take sine of which angle?
Theta 1, sir.
The angle between other two forces. What is included angle between other two forces? Theta 1.
Theta 1,
That
sir.
TAC divided by sine of angle between
Theta
other TBC, sine of theta.
2.
Right? If you don't want to find it by using Lami's theorem, then how you gonna find out? Just the regular procedure like summation of forces along vertical 0. Let's see if I take summation of forces along y is equal to 0. What I will get? VA plus VB should be 0. If I take summation of forces along x equal to 0, sorry, VA plus VB is equal to downward force 10. If I take the horizontal forces, HA plus HB is equal to 0. And then take moments are equal to 0. Now, look at this type of structure and tell me at what point if I take summation of moments is equal to 0, can I able to find any one unknown?
See, sir. No.
Think about the point at which if I take the summation of moments are 0, any one unknown can I find?
C, sir.
At C. If you look at C and if you take summation of moments equal to 0, can you tell me what is the equation you will get? Because of VA moment will come, because of HA moment will come, because of VB moment will come, because of HB is also moment will come. Right or wrong? If I take summation of moments at C, before that, can you tell me what is the equation? Summation of moments is equal to 0, what you will get?
Sir, we take either one side or both sides, sir.
Huh?
We take either one side or both sides.
What I am saying, which equation I am talking about?
Summation of moment about C.
Whenever we are talking about summation, then
The whole
we have to
picture.
look into all forces.
Okay,
Summation means everything.
sir. Okay.
If I take MC is equal to 0, I just want to see the difference of these two from you guys. First of all, tell me about this equation. If I take summation of moments at point C equal to 0, what is the equation I'll get it?
HB into 1.
HB into 1, let us anti-clockwise, so minus
Minus 1.
V into 1,
VB into 3 minus
so VB into 3,
plus HA into 1
and then
plus
V also clockwise, plus
VA into 2.
equal to 0.
Yes, sir.
If you are talking about summation, you have to take it all forces. If I am talking about MC is equal to 0, this I can define either by looking at the right or I can look at from the left. If I look at from the right, equation will consist of HB and VB. If I look into the left, the equation will consist of HA and VB.
VA.
Now tell me at what point if I can take summation of moments 0, I can find any one unknown. You can take right summation of moments either at point A 0 or at point B is equal to 0. I can take. Can I?
Yes, sir.
If we take summation of moments at point A equal to 0, because of this no reaction, because of this
No reaction.
no reaction. Why? Because these are at the same level. So if you take summation of moment at A is equal to 0, what unknown you will get? You will get VB. If you take summation of moment at B equal to 0, what you will get? you will get VA. Isn't it?
Yes, sir.
After getting VB, what is the next step I should do? I have to find either this force or this force. For that, what I have to do?
Summation.
Summation moment. What happens if I take MC is equal to 0? Let's say I have found the VB. If I found MC is equal to 0, what I will get it? What is the moment equation if I take at points equal to 0? Look into the right side because of HB. Anticlockwise, HB into 1. VB also anticlockwise, VB into 3. That will be equal to 0. So if I got VB, can't I find HB then? First of all, you do one thing. Let us solve this problem in terms of two ways. First one is find the support reactions first. Based on them, find the forces in the member. And in the second case, what you will do, first you will find forces in the members and then you will find support reaction. So let us find out the first step. Find the support reaction for that. Take either summation of moment at point A 0 or at point B equal to 0 and tell me what you are getting. Use this equation and tell me how much you are getting or what you are getting. Take summation of moments at point A equal to 0 and tell me which reaction you are getting.
Sir, if summation moment at A equal to 0,
Yeah.
VB equal to 4.
VB equal to
4.
Now, without doing that also can I find VB in a simple trick, like if there is a simply supported beam, the distances are 2 meter and 3 meter and the load is 10 kilonewton. What do you think the reaction here will be? And what do you think the reaction here will be? What about the reaction here? Load into what is the opposite?
3, sir.
Load into total length. How much you are getting? 4. Here we will get it as 6. Are we getting the same answers or different answers? Here, even if it is moment equal to 0, we are getting VPS 4 kilonewton. That's what we have found. Even in arches also we have done the same thing. But what is the rule that you have to remember? That this directly you can write down only if supports are at same level. You can see A and B, are they at same level? Yes, because as they are same level, your reactions you can find out directly here. What if they are not at the same level? What do you think the changes will be? If they are not at the same level, where the difference will come? Have you got the question?
Length.
Imagine there is a support here and there is some support here. Again, the same thing. VA, HA, VB, HP. Let's say the force is 10 kilonewton. Again, 2 meter, 3 meter, 0.5, 0.5. Now, can you tell me what is the equation for the previous case here? You have got it as VB into somewhere around 5 minus or plus 10 into 2. That will be equal to 0, right? There may be plus or minus. Okay, anti-clockwise minus, that's right. Now, similarly, can you tell me what is the summation of moments equation here? What is the moment equation? Because of VB, here it is minus, here it is plus. Minus VB into 5 plus 10 into 2. Are there any other moments?
3.
Are there any other moments will act here? Or that's it?
If that's the point,
Any other moments will come or it will be as it is the same?
it will
That's
come,
it,
sir.
sir.
That 0.5 distance.
Huh?
That's all, sir.
That's all. Look at this force HB.
So no, sir. 0.5.
Be any moment or not?
Yes, sir.
0. It will be 0, sir.
No, sir. No, sir.
No, there
It's
is a
not a
perpendicular
symmetrical.
between
It's
these
not a
two.
symmetrical.
It will make a clockwise plus HB into 0.5. Now you can understand what is the difference here in between these two equations.
Yeah.
This term.
For difference level, it will be HB, sir.
So whenever the supports are not at the same level, because of the horizontal reactions also, movements will develop at one end. So because of this term, we cannot directly write like this. But if the supports are same level, whatever may be the type of the structure, it may be arches, it may be cable, doesn't matter. But we can use this equation. Okay. Now you found VA. Okay. Now you found VB. Based on that, you can say your VA is nothing but a 10 minus 4, that will be equal to 6. Now tell me, how can I find the horizontal reaction? How to find horizontal reaction now? As we have told you, you can take moment at point C is equal to 0. Not only at point C, in between you can take moment at any point is equal to 0, like you wish. But if you ask me why I'm taking moment at equal to 0, this length is directly given. This from here to here, it is 1 meter directly given. So that's why I'm taking moment at C equal to 0, so that I know all the perpendicular distances. Now what is the moment equation? Because of this HV into 1, VB into 3. Both are anti-clockwise. Minus HV into 1 minus VB into 3. That will be equal to 0. That implies you can tell me your HA will be VB into 3. VB into 3.
Minus 3 VB, sir.
VB is nothing but 12.
12.
What is the direction? We have assumed it as left side, but it is of 12 kilometer was acting on the right side. After that, how can I find the reaction? If you look at the joint B, sorry, this is B, right? If you look at the joint B, here it is upward force. How much? 4. There is a force of 12 kilonewton. Then here if it is your tensile force in the member BC. How about this magnitude then? How can I find this? Directly, can you tell me without taking any angle? You can imagine if I rearrange these two forces such that tails of the forces will meet, what will be the resultant of these two? Under the root 4 square plus whole square. That implies, can you tell me what is the force in the member BC? That is nothing but under the root 4 square plus whole square. Is it clear this equation how I have written?
Yes, sir.
If two perpendicular forces are there, then obviously the resultant force will be square root of both. And then
Yes.
that is what nothing but your force in BC. Similarly, you can find it for TAC also. So this is one way of doing this. First part we have done support reactions and then forces in the members. The other way, as I told you, first use the Lam's theorem, find out the forces in the members, and then find out the reactions HA and VA. So whatever the way you are comfortable, you can do it. So for cables, these are the basic sense only we can solve it. Nothing else. We don't need any special knowledge to solve this. Can I give you one problem? You can solve it. Imagine there is a load 10 kilonewton and there is a load of 20 kilonewton. From here to here it is 1 meter. From here to here, let us say it is 2 meters. 3 meters, 4 meters, and 5 meters. Now, tell me how to proceed this problem. Finally, what I need is I need forces in the members, support reactions. Is it clear the both, either how to find support, either from supports to members or from members to supports? Is it clear?
Yes, sir.
Is it clear how to find from reactions to forces in the members and forces to support reaction? Now, in this case, choose any of method you like. But tell me, what are the forces in the members?
HAVB.
Take 5 minutes of time. No issue. Think about it and how we will. You just have to play with the equations only.
Yes, sir.
And one more thing you should notice that did they give you this site? No, right? This is also unknown that you have to consider. Any ideas?
No, sir.
No.
Yes,
Now,
sir.
first of all, tell me, can I apply Lam's theorem at joint C? First question is, can I apply Lam's theorem at C? If I can apply, can I find the unknowns or not?
Sir. Yes, sir. We do, sir.
Can I or I cannot?
Yes, sir. Can be, sir.
We can. How?
Because 3.
If I take Lam's theorem at C, right?
Yes, sir.
What are the unknowns are there? EAT is the unknown. TCD is the unknown. In
Yes, sir.
addition to what we need the slopes, isn't it?
Yes, sir.
Now from here to here we know 3, but do we know the value of H? If you don't know this value of H, then how can you find the slope here? Can you find the slope here?
No.
We cannot. Then if we cannot, then we cannot find out. Similarly, even if you want to apply here, we have to find the slope of this member CD. The slope of member CD can't be found if you don't know this H value. So, as we don't know this value of H, we cannot directly apply the Lam's theorem. So what we have left with? We have left with traditional equations, isn't it? So let me imagine the reactions first. So here, let me say there is a vertical reaction here, and there is a horizontal reaction, HC. Similarly, there is a vertical reaction, VB. There is a horizontal reaction. Now, tell me the equation by taking summation of moments at point A is equal to 0. Can you tell me?
So 10 into 3. Positive.
Clockwise.
Sir, can I say the final equation or fully, sir?
20 into 3.
Same, right? 10 into final equation also same, right? 10 into 3.
20 into 7.
4.
7, sir.
Yeah.
Plus
Yeah.
minus 3 into 9. 12, sir. And HA into 1.
HB. So minus HB. Minus HB into 1.
Clockwise.
Oh, minus
Plus
3.
3 into
Clockwise moment. Because of this HB at this joint clockwise left. Just look at the reaction here. Whether you have taken right side or left. Maybe it might depend on that.
So I've taken left side.
Yeah. Maybe. So how many unknowns are
Final
there?
equation.
Yeah.
2 unknowns, sir.
Here there are 2 unknowns, right? VB and SB. So if you want to solve it, I need one more equation that should be in the combination of VB and HB. Can you think of any one equation in that it will be of unknowns of both VB and HB, not more than that.
Take moment about C. Right side, sir.
Take moment at D is equal to 0. Which side I should look into? Do I have to look into right side or right side, isn't it?
Yes,
So if
sir.
I look into the right side, then I can know.
Minus 20 into 5.
Minus.
No, sir. Minus 20 into 5.
How come 20? Why does moment will come? Because of this 20.
20 won't come. 20 won't come.
VB, sir.
So VB into Y anti-clockwise. Because of HB, clockwise.
Clock into 3.
3.
3, sir.
Plus 2. 3 that should be equal to 0. Now we have 2 unknowns here also 2 unknowns. Can you quickly find out?
Yes, sir.
Sir, will RB will be in decimal, sir?
RB will be?
Will it be in decimal?
Means?
So it will be in decimal point or whole number, sir?
Obviously it will be decimal. There is no other option.
VB will be 4.15.
Is it right? I don't have any values. You guys Let's confirm with others. So tell me one thing, if you are solving this, which one you have substituted in the equations? Have you substituted HB or have you substituted BB? If I will be in your position, what I'll do, as HB is a single value here, directly I will take HB with VB. If I take this side without writing anything, my HB is just nothing but a 5 by 3. It's around 1.667 VB. So I know this value 1.667. So total my reaction will be, it will be minus. So 10.33 VB. And then if it is an exam hall, that's how you should directly do the calculation in your head and then do the final calculation.
Okay.
How much you are getting finally, VB?
So VB 16.45 VB.
16.4.
Yeah.
Which is correct answer? Please confirm it. Guys, one more please. Otherwise, I have to do the calculation part. Please do it. Which one is right? Yeah, it's around 16.45.
Yes.
Now what? HP is 1.667 times VB. So what is the final value? HP will be 27.4.
27.420.
And what about HA? Now I know HV and VB, then what about HA? Any other horizontal forces?
27.43 minus 27.43.
Yeah. If it is on the right side, obviously it will be on the left side. So 27.43. And VB will be 16.4. Good. You can look in total downward forces. 10 plus 20, 30. 30 minus
13.53.
13.5. Now by looking at this value, can you directly tell me what is your tensile force in the member AC? What is your tensile force in the member BD? What can be the tensile force in the member AC? Now you know the reactions at the supports. If you know the reactions at the supports, can you simply tell me what will be your member forces? Just now as in TS is nothing but a under the root HA square plus VA square. And TBD is nothing but a HB square plus VB square. After that, how can I find the remaining force in the member TCD? So if I want to find the TCD, how many methods I can approach? For that, either I have to take Lamis theorem here or Lamis theorem here. Before that, I need to find out the value of H. If I don't know for H, I cannot apply the Lamis theorem either at C or at D. So tell me, how can I find this value H? Now you know the support reactions. Now you know the forces in the members AC and BD also. How can I find out the value H?
Sir, first we have to find theta, sir. After finding theta, we can find H. Sir.
Yeah. Anything. If you find theta, it can be fine. If you can find H, theta can be also be fine. Vice versa. What happens if I take moment at C equal to 0? What is the equation if I take moment at C equal to 0? Look at from left side, and what is the equation you will get? Because of HA, what is the moment?
13.
times H, anti-clockwise, negative. Because of VA clockwise, VA times 3, that will be equal to 0. Now we know VA and you know HA. That means H can be found from here. Now find the value H and apply the Lamis theorem at point C, and then tell me what is the force in the member CD. What is H value first of all?
1.48.
1.48, sir.
1.48.
1.48.
Lamis theorem at C. Let's see if I apply here. This is TAC, and here it is TCD, and here it is 10. Now I need to interested in finding these values. Theta 1, theta 2, theta 3. So please tell me these values. You want me to tell this slide? Why it's taking so much time? So whatever this value, let us say alpha. Alpha is nothing but I can say tan inverse of 3 by h 1.48. What is this difference? From here to here, 2. From here to here, 1.48. So what about this difference? 2 minus 1.48, 0.52. So if I assume this as my beta, what will be my beta? My beta is nothing but a tan inverse of 0.52 divided by, from here to here the length is 4. Can somebody please tell me what are these values?
Sir, alpha value 63.74.
63.74. Beta.
Beta 7.41.
So I know from this theta 1 can I express this as 180 minus alpha. From here to here total angle is 180. This here to here it is alpha. So what about this angle? Theta 1 is 180 minus alpha. These two are 90 degrees. This angle is beta. So what about theta 2? From here to here, if this is theta 2, that is nothing but from here to here, alpha plus 90 degrees plus beta. And what about if this is theta 3? What about theta 3? That is nothing but from here to here beta. I can say it as 90 minus beta. Now you know TAC also. Only one unknown. TFDP you can find out, that's it. The job is done. Now in this case, can you tell me? Can we find support reactions and member forces? Previously, we have only one unknown, that is H. Now, if I give you one more unknown too, that is H1 and H2. Think about it and tell me, can we solve just like what are the things that we have done?
Sir, we can solve.
Try it and let me know. Take 5 minutes of time, think about it and let me know. Can we solve it or not? For cable, there is nothing to discuss specially. If just whatever the things you know, you just have to know how to apply it. That's it. If its previous problem is clear, use the similar strategies and tell me if you can find and tell me the ways how to proceed. Can we? Okay, now let us forget about whether solve it or not, but how much time do you think it might take? Even the previous case, I can tell you it can take around 3 minutes if you want to do it correctly. Now, if I increase the complexity more, it might take up to 5 minutes also, right? Things can be solved in somehow in one way, but how much time it will take, that's also matters, right? So in the exam, don't expect that they don't ask you not more than one unknown like here H. Or even if they ask you, definitely they might give you the relation or they might give you the reactions. If I give you the reactions, can you find out? On the same, suppose let us say, if I given you vertical reaction, if I given you horizontal reaction, can you find this H2 and H1? If I given you this as 20 kilonewton, let us say around 19. If I given you this as 15, can you find this H2 quickly? Am I audible?
Sir, audible, sir.
You can write, obviously. So the thing is, if they want to simplify the problem, they can simplify it anyway. Like they might give you the reactions, then also you can find out. If they give you relationship between H1 and H2, then also we can find out. And there are some problems like they might keep you a rigid bar somewhere here. and then we have to take the sides are equal. So they might give you the different conditions, but what are the procedure we have done it for the previous problem, the same procedures we have to follow, and then we have to get the answer. Right? It's not obviously we are going for the competitive exam, and don't expect that they will give this much of complexity. Clear? Now, even let us talk about the UDL loadings. Now, imagine there is a cable. If it is subjected to UDL loading, then this shape might be, the deflected shape might be in the form of parabolic. Now here the point is where I am applying the loading. If I apply the load on the horizontal span, that means there will be another span. Imagine this is your girder and the cable will be connected through another cable, sequence of cables like this. You guys might have seen this type of structures too in cables. So if the UDL loading it is acting on the girder, then the deflected shape of the profile will be parabola. There is another case that the best example I can tell you it is a self-weight. If the load is also acting on the cable itself, then here the shape will be catenary shape. So here UDL it is acting on the horizontal span. Here the UDL along cable. So this they might ask you for one more question. If there is a UDL that is acting on the horizontal, the position of the wire will be parabolic, and if it is along the cable, then it will be catenary. And solving this is not easy as it looks like. Why? Because here if you see the loading is acting on the horizontal span. That means the loading is truly acting on the vertical, truly acting along vertical direction. But here, if I take each and every point, what do you think is my load is acting truly on the vertical? Are they truly acting on the horizontal? No. The direction of the loading is also depending upon the slope of the parabolic profile. And again, I'm telling you, solving this will not complete within 5 minutes. So only you just know that if it is UDL acting along the cable, the deflected shape will be different. More than that, even if you go through, it will be a waste of time only. No competitive exam, they won't ask you this type of question, but for parabolic, they can ask us because this can be solved, even though it might be complicated, but this can be small. And let us try to solve this case. There are 3 points that we have to identify. If there is a UDL loading that is on the horizontal span, we should find out where the maximum reaction develops. We have to see where the minimum reaction develops. The minimum reaction will always be developed along the lowest point of cable profile. So wherever the cable profile is least, there you will have the minimum tension. Similarly, in the same way, I can tell you where can be the maximum tension possible. The tension possible can be topmost point, right? Just vice versa. If it is a minimum, lowest. If it is a maximum, then we can say highest point on the table. Now look at this. Now in this case, these are at the same level, suppose. Now I can say that at this point, the tension in the cable, at this point, the tension in the cable will be same way because they both are at the same level. Now in the exam, if they ask you, where will you get the least, or they ask you what is the minimum tensile force that is developed in the cable, then wherever there is a maximum or wherever there is a lowest point, At this point, we can find out the minimum. We have seen in simply supported beams also that wherever there is a maximum deflection, we know that the slope will be equal to 0. Even here also, as we are talking about the least point, we can say that the slope here will be is equal to 0 too. Yeah. Now, let us solve a problem here. Let us first solve if both are at the same level, and then in the next case, we'll solve it. Imagine that UDL is acting on the horizontal beam, let us say acting it is 10 kilonewton per meter, and imagine the total length is 200 meters. And they have given that the maximum sag that occurs nothing but a span divided by 20. Now here we have to find out the support reactions, and we have to find out where the maximum tension develops in the cable, and also we have to see where will the minimum tension develops in the cable. Now, first of all, what is the components that we can find easily? Like, what are the components that I can directly say whether they can be a horizontal reaction or they can be a vertical reaction? This is symmetrical, right? If this is symmetrical, I know I can find the vertical reaction.
Vertical reaction.
Think the total vertical reaction. Total load by 2 as it is symmetrical. What is the total load? 200 into 10, 2000. 1000 kilonewtons and 1000 kilonewtons. Now done. How can I find out the horizontal reactions now? There will be horizontal reaction here. There will be the horizontal reaction here. How can I find out HV or HV? Just like the same way, how we have solved. What point we have to take is equal to 0.
TRB.
As the maximum sag is given as span by 10. So let us say this is the maximum sag point. They have directly given the value. Then I can count at points equal to 0. From this, if you look into the right side, because of HB, what is the reaction? HB times span by 20 positive, because of 1000 anti-clockwise. 1000 into, what about
1000 into 100.
that will be equal to 0. Can you tell me what about your HB?
10,000.
HB is nothing but a
10,000.
right? Now, let us say if I talk about some point, let us say some point D dash. How can I find out the tension in the cable at the point D dash? What we should do? First of all, at point A, what is the tension in the cable? Tension in the cable at point A, what I can simply say that is nothing but under the root HA square plus VA square. Similarly, what is the tension in the cable at B? Similarly, nothing but HB square plus VB square. Just like that, imagine I have taken a point somewhere around at D dash. Now my task is to find out what will be my tension in the cable at point D dash. How can we solve it? What will you suggest? Just think about it and tell me. Let us draw the free body diagram. The span TD. We know the force here, that is nothing but 1000, and we know the force here, that is nothing but 10,000, and then UDL is acting over here 10 kilonewton per meter. Let us say we are considering a span of 10 meters, right? Any other forces that will act here?
No, sir.
We have to, as we
Sir,
are operating at this point, here we have to consider there is a tension in the cable T A D dash. tension in the cable at D dash. Let us represent it as it. And let us imagine that the slope of the cable is theta. How can I find out TD? I can use equilibrium equations, right? Either I can use summation of x is 0, either I can use summation Fy is also equal to 0. Now, how can you say then? What will be the equation if you take summation of forces along x equal to 0? Along x equal to 0, if you take how many forces are there?
10,000
10,000.
and
10,000.
loads.
And then if you resolve this force, what is the component here? TD dash cos theta.
Cos theta.
If you talk about the vertical component, TD dash.
TD dash sin theta.
If you take along horizontal 10,000 left side, TD dash right side. If you take this as a negative or plus, TD dash cos theta is equal to 0. Right? Or even if you take summation of forces along y is equal to 0, then upward force 1000, downward force minus 10 into 10, and again I am imagining it is a downward, so minus TD dash sin theta is equal to 0. Now the point is how to find out the angle theta. How can you find out the angle theta?
Dividing the two equations, sir. Sine by cos tan.
Even if you divide this equation, it's of no help. Yeah, if you divide it here, TD gets cancelled, but yeah, but that's not the point I'm interested in. But what is the other way of finding the angle? If I told you, right, if it is a horizontal component, what will be the shape? It will be in the form of parabolic. If it is in the form of parabolic, what is the variation? Y will be equal to 4h by L square into x into L minus x. Now what we are interested in? We are interested in finding theta. That implies we can take dy by dx, that will be equal to 4h by L square into L minus 2x. What about h here? Here h is nothing but a span divided by 20, whatever given in the question. And x, in the present case, x is given as 10 meter and the length is given as 200. So if we can find out this, the other component can also be found. So wherever if you need the tension force in between any point, so find out the angle and then apply the equilibrium equation, still you will get it. If the cable is lying somewhere around here, imagine the distance is 2 meters, the total span is again 200 meters, and let us say from here to here it is span by 20, A, B, and again the horizontal load is acting. Can you quickly find out same load, 10 kilonewton per meter? What will be your reactions? And then find out the maximum tension in the cable. Can you tell me here, what is the tension at cable C at this point C? Look at this diagram and tell me what is the tension at point C. Without doing any calculations, we can say it directly. What is the tension at point C? At point C, what is the slope? What is the slope at point C?
0.
0. If it is, if for the free body diagram, this will be truly horizontal, isn't it?
Yes, sir.
So in this case, it is inclined. But if here, if you talk about it, will be truly horizontal. Now this is your thing. Now, what will be your reaction then? PC.
10,000.
10,000.
This is also horizontal. This is also horizontal. To balance this,
10,000.
right? Similarly, quickly find out what can be the reactions here and what can be the reactions here. Imagine from here to here, I have given it as 95 meters. Not 95, around 1 knot meters. At least where will be the maximum tension possible and where will be the minimum tension possible. And if I'm talking about point C, you can write, let it be. So for cables, don't go beyond whatever we have discussed today. So we haven't discussed anything new. Whatever we have known as of now, those are the things that we have applied today also. So for cables, it's nothing new that we should learn. It's about how the knowledge, whatever we have gained, that's what we should apply. That's it. Even if you go beyond this, whatever we have discussed, that will be waste of time and nothing. If you want to by heart any equations, if you want, go through the standard books and by heart them. But other than that, I am telling it will be a waste of time. So what we'll do one thing. We'll stop here today, and then our last class will be next class. I don't know when it will be, either tomorrow or day after tomorrow. There we'll see a general for normal determinant structures. Let's find out how to find the deflections, and then let's see the strain energy theorems, Castigliano's theorems, Bettis reciprocal theorems. Those are the simple things we'll discuss in the last class. Okay, and with that
Okay.
we can end. Okay, thank you for today.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.